Ladies and gentlemen, welcome to the Kalmar booth to hear more about robotics in this demo session. I'm Lasse Eriksson, heading technology for Kalmar Mobile Solutions, and you will hear more about our autonomous Kalmar terminal tractor during this demo session. So we'll talk about robotics, and robotics is a key technology. It's a range of technologies that allow us to bring more intelligence to the machines. And let's look into some of the benefits that this approach provides us with. So we'll look into actually 4 use cases of robotics during this session. And first of them is self-driving operation or autonomous operation. The second one will be about safe driving in mixed traffic. And third one is about infrastructure and the cost related to that, and what benefits actually robotics can bring into that context. And finally, we'll talk about the scalability of this approach to other segments of industry. So let's get going and kick this off. And as I said, let's first talk about autonomous driving or self-driving in operation. So autonomous driving basically means that the machine itself, the equipment itself, is able to both localize itself, navigate itself, plan the path itself, and do other operations, material handling operations, autonomously. So let's look into it, what it actually means in practice. We have a great video here about our RoboTractor development and testing at our customer site. And this is showing how the machine will be able to operate in any kind of any conditions based on this autonomous technology. So what we see here is that actually the machine has been equipped with a lot of different sensors and computational power and actuation capabilities in order for it to operate in this kind of an environment. What it actually does, it kind of calculates its position autonomously. So it's not dependent on any, let's say, infrastructure or any kind of a automation system as such, but it can do that positioning independently of that. So this is a kind of the way that autonomous driving actually works, and really the benefits I will address more. This is a key enabler for other benefits that the robotics approach actually delivers us. And one of the main benefits that actually comes with autonomous driving is the capability to drive in mixed traffic. And we always know that our machines, these type of equipment, are always operating in an environment where we have, to some extent, people, service vans, material handling equipment, either manual or autonomous. So it is important that the machines will be able to detect, of course, people around themselves, as well as to prevent whatever safety hazards that could happen. Let's look into it once again, how it works. This is again a video of our RoboTractor at our customer site. And with the capabilities that it has to perceive the environment, and you see some of the sensors in the machine there, and we'll look into that more closely in another use case. But the machine itself, as you can see, it's able to stop and prevent any kind of collisions with, let's say, dynamic objects, if you call people walking around like dynamic objects. So this is a key, that every single machine is able to prevent such accidents and enable thus, of course, efficient operations even in mixed traffic. Of course, we should not create the environment such that it's a kind of wild west type of scenario where we have everybody going around and around. That's not the case. But in case we need to have people around the machines, it's still possible to operate autonomously and efficiently, because the machines have the capabilities to stop whenever needed. So let's move on to the next benefit and talk a little bit more about actually infrastructure impact. As I mentioned, the navigation capabilities of the machines are actually in the machine. So navigation is very much based on the kind of the sensors that the machines are equipped with. So the mapping and the kind of localization of the machine is not dependent on, let's say, transponders underground or such heavy infrastructure investments. So this is fairly simple technology to deploy in practice in new scenarios and new locations and sites. And this has a big impact on the infrastructure needs. And this is a little bit what we want to demonstrate with this video, where you see a little bit more closely the different kind of sensing capabilities that the machine is equipped with. So we can see a lot of cameras and radars and lidars and sensors like that. And ultimately, this all data, the data that we receive through these different sensors, is utilized to build actually the kind of location of the machine. And this is based on the fact that we have mapped the environment using the same sensors. So we know, in a way, how to correlate this particular position into the map. And here you see some of the, let's say, readings from and data from the sensors, how it actually looks like. And this type of information is actually then used to position accurately the machine in real time. So we are not using any infrastructure, let's say, localization methods in this case, and this has a big impact on the cost of the deployment. So that's another benefit of robotics. And let's move on and still look into the final use case. And this is about actually scalability of the technology into different segments. And by this, what we mean is that the core technology for autonomous driving is universal. Automotive industry is developing a lot this technology. And you see in your cars, if you have a recently bought or relatively new car, you see this technology there as well. You have some autonomous driving capabilities there. Of course, not the full scale, but some of that. That same technology development can be utilized in our industry to make our equipment to be more autonomous. And this is, of course, beneficial because the scalability is good. And thus, of course, the cost of development and speed of development is lower. So let's look at another video which presents actually our RoboLifter, which is an autonomous forklift truck in operations at the sawmill. And in this case, you see that actually the autonomous driving technology is exactly the same as in the RoboTractor case, but only then the specifics of the load handling is different. And as you can see here, for instance, the machine is able to identify objects that are not supposed to be on the ground. It can stop and it can reroute itself to find another route to the targeted end location. So once again, the scalability of the technology is very good. It allows us to deploy this efficiently in many of our customer segments. So in summary, this takes us to the end, and we have gone through 4 different use cases of robotics and discussed the benefits especially. And key technology there is the autonomous driving that enables us to have autonomous machines in mixed mode traffic scenarios at our customer sites. We can reduce the cost of infrastructure by applying this approach, as well as we can see the scalability of this one, which allows this to be, of course, deployed in many of the customer segments. And this is basically the thing with the autonomous driving. And to the end, Kalmar robotic portfolio that was launched at the end of last year, this is targeting to this kind of fully autonomous unmanned material handling applications and solutions to our customers. And with this approach, we see that we will be able to deliver solutions that have basically 0 accidents, 0 emissions, and maximum productivity to our customers. So this is the technology where we believe in. This is a fundamental technology shift in our industry, and we believe this has a big impact on safety and sustainability going forward. So thank you very much for your attention. This was a brief summary of robotics. I hope to have very good discussions afterwards here at the Kalmar booth as well. Thank you.